Dear students, நாம இப்போ இந்த வீடியோவில் பார்க்க போது +2 Physics தமிழ்நாடு ஸ்டேட் போர்ட் ஃபர்ஸ்ட் சாப்டர் எலக்ட்ரோஸ்டாட்டிக்ஸ். மறக்காமல் இந்த சேனல் சப்ஸ்கிரைப் பண்ணிக்கோங்க. இப்போ நாம் இந்த வீடியோவில் பார்க்க போகிற டாபிக் எலக்ட்ரோஸ்டாட்டிக் பொட்டன்ஷியல் எனர்ஜி அண்ட் எலக்ட்ரோஸ்டாட்டிக் பொட்டன்ஷியல். To calculate the electrostatic potential energy and the electrostatic potential, consider a positive charge plus Q, which is kept at a fixed point that you can take it as a origin, and that produces an electric field E around it. You should bring a positive test charge Q dash from a point R to the point P. So there should be a force, a repulsive force between the two charges Q and Q dash, and you should bring this test charge against that repulsive force. Now, to bring this test charge to the point P, work must be done to overcome the repulsive force, and that work done is stored as potential energy. Now, if you bring the test charge Q dash from the point R to the point P with constant velocity, that means an external force is used to bring the test charge Q dash from R to the point P. That must be equal and opposite to each other. That is the Coulomb force. So here the Coulomb force, if you take it as F Coulomb, the external force is F external, and that should be equal and opposite. Therefore, the work done is given by W equal to integral R to P F external dot dr. That you can take it as equation 1.25. Then the Coulomb force is conservative, and therefore the work done is independent of the path, and it depends only on the initial and final positions of the test charge. If the potential energy associated with Q dash at P is UP and that at R is UR, then the potential difference in the energy is given by the work done in bringing the unit charge, that is the test charge Q dash from the point R to P, and that is given as UP minus UR. That is equal to W, and that's equal to delta U. Therefore, the equation can be written as delta U equal to integral R to P F external dot dr. And the external force will be equal and opposite to the Coulomb force, that is equal to minus Q dash E. Therefore, the change in the potential energy is given by delta U equal to integral R to P minus Q dash E dot dr, and thus equal to Q dash integral R to P minus E dot dr. So the potential energy difference per unit charge is given by delta U by Q dash, and that's equal to Q dash integral R to P minus E dot dr by Q dash, and that's equal to minus integral R to P E dot dr. So this equation 1.29 is independent of Q dash. That means the quantity delta U by Q dash equal to minus R to P E dot dr, that is called electric potential difference between P and R, and is denoted as Vp minus Vr equal to delta V. So we can define the electric potential energy difference, that is the electric potential energy difference, as the work done by an external force to bring unit positive charge from the point R to the point P is given by Vp minus Vr, and that is equal to delta V, that's equal to integral R to P minus E dot dr. So that you can take it as equation 1.30. So the electric potential energy difference that can be defined as follows, that is the equation can be written as delta U equal to Q dash delta V, that is shown here. This equation delta U equal to Q dash delta V. and so this is the equation delta equal to q dash delta v, and the potential difference between the 2 points is a meaningful quantity. That means the value of the potential itself at one point is not meaningful. Therefore, the point R is taken at infinity and its potential is considered as 0. And the electric potential at a point P is equal to the work done by an external force to bring unit positive charge with constant velocity from infinity to the point P in the region of the external electric field E. So the definition itself can be written as mathematically like this, that is Vp equal to minus integral infinity to the point P E dot dr. Now we have to consider some important points. The first point is the electric potential at a point P depends only on the electric field, which is due to the source charge Q and not on the test charge Q dash. So the unit positive charge is brought from infinity to the point P with constant velocity because the external agency should not impart any kinetic energy to the test charge. And from the equation 1.29, the unit of electric potential is joule per coulomb, but the practical unit is volt, which is named after the scientist Alessandro Volta, who has invented the electrical battery. Now the potential difference between 2 points is expressed in terms of voltage. So these are the two important points that we should consider in this topic. இது வரைக்கும் இந்த சேனல் சப்ஸ்கிரைப் பண்ணாதவங்க சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ.